Let's go over proper testing of Tyco fire suppression and detection systems. To determine the proper test method for a heat detector, it would be best to first understand what condition it is engineered to detect. I can hear you now. A fire, you fool. It's used to detect a fire. I would agree with you. It is used to detect a fire. But how? The most common heat detector, which utilizes a rate of rise function, is designed to detect a rise in temperature of greater than 15 degrees Fahrenheit over a 1-minute time period. If the temperature rises this fast, it likely isn't coming from someone who ate baked beans for breakfast. It is more likely the heat generated from a fire. To understand how this is accomplished, you need to think back. Some of us will have to think way back to grade 10 physics class. Remember when the teacher took an inflated balloon and then held it in the airstream coming from a hairdryer? If your memory doesn't fail you, you probably recall that the balloon expanded in size, and that is the same way a common rate of rise heat detector works. The flexible baffle is like one side of a balloon. Normally there is equal air pressure on either side of that baffle, so it stays unflexed and flat. There is a set of normally open electrical contacts inside the detector which connect to the fire alarm system. When those contacts short together, the fire panel signals an alarm condition. Now that we understand the true conditions that these rate of rise heat detectors have been ULC listed to detect, we should do our best to simulate those exact conditions to determine if each heat detector is still able to perform its duties as expected. Unfortunately, it's common for some of these heat detectors to be tested with a device that anyone can purchase at their local convenience store. In case you're wondering, it looks like this. Butane burns at over 3,500 degrees Fahrenheit. These heat detectors are not designed to withstand such a large difference in ambient room temperature. If you think about it like this, it would be like comparing a warmed baby's bottle to a campfire. Using this type of device to test a rate of rise heat detector is, at best, non-compliant, as it does not simulate the conditions that the device is engineered to detect. However, the real danger lies elsewhere, as the high temperature exposure could very easily damage the seals surrounding the flexible baffle inside the device, thereby compromising its ability to perform when an emergency condition occurs. Exposure to such a high temperature from a butane lighter can definitely result in permanent damage to the baffle seal on the interior of the heat detector. Understand that the telltale evidence of a heat detector which was tested by using an open flame is often visible. It is a black sooty smudge or deposit on the exterior of the heat detector shell. Understand that professional testing tools are available which can be used to test heat detectors properly. As a building owner, what should you do if your heat detectors are being tested in this manner? Simple. Stop the test. Stop damaging your devices. Hire a company that knows what they are doing.